Hello everyone, and welcome to Excited English channel. So today we are going to learn about iterators and generators. Basically, what are iterators? Are so there is one question that might I don't know that you might have wondered or not, that how does Python remember where it left off in the loop like for example, let's say we have a loop like this. So how does Python remember that? Okay, I have done the you can say zeroth index, and now it's time for the second. So the answer for that lies in the iterators basically. So what are iterators? So iterators are nothing but just an object that gives the value one by one. So if I have to, you can say, relate it to the real life example. So you can say that if you binge watch the Netflix, then you have noticed that you watch a video at a time, not the whole series at once. So this kind of thing is what iterator really is. So if taking the example of this kind of list is that if I'm taking the example of this list, and let's say I am just going to first of all comment that we have a numbers list, and this is this list. Now how the iterator works is, let's say the it represents the one iteration, or you can say iter. Then we use the iter you can say string iter method, and in the iter method we pass the list of numbers. Now what we need to do is we need to print the it here first of all, and when I print that, of course it is not going to return us with anything, but what if I say okay, next. So next is a method. Next is a method that help us print the value behind the you can say contained, or you can say it is more of like a pointer in C++ that the next method, basically the next method prints or give us value behind the IT. So this is something that you must you know say think about every time. Now what if I try to even say print IT every time again and again? Now this time you get to see the answer of it. Now let's say I you can say write this n times. So as you can see, for the elements, that means we have three elements. So the three next statement return us the three elements, but at the fourth line it returns us an error, and the error suggests that okay, the list is completed, please stop it. That means the iteration is going to stop here. So the key concepts here is that the iter basically creates maybe I should comment it that here the iter creates an iterator. Iterator is something you can say collection or things in which things from which we can get the value one by one by one. Now this is something that you must keep in mind every time. And also the next line, or you can say the next element in the iterator. So, and when we are finished with the iteration, we get a stop iteration error, which you have seen in the this you can say called. Now the other thing is that why the iterators matter. So iterators matter because it saves us some memory. and also it helps us work with the large data, and it is used in the loops internally. So these are the, you can say, three things that I will say that why the iterator matters. If I have to put it here, let's say, as you can see, this answers our question that how the loops are worked internally. So this kind of thing is what important to us. Now the next thing is that what are generators? So generators are nothing but a simpler way to create the, you can say, iterators. So let's see what are some kind of generator. So generator is a function. Let's create a function my gen, and in this function, what we are going to, oh sorry, what we are going to do is we are going to yield one, and in a similar way, let us yield some more things like say 3, 4. Now, let's say G is equal to generator, my generator. So when I try to create this my generator here, what it is going to return us, let's print the G here first. So when I print the G, it basically generated an object at some location. And if I try to, you can say, put a next word here. So as you can see, when I try to, you can say, use the generator here, it returns us the value 1. So what this yield keyword does is basically poses the function yield, basically yield poses the function and to return the value, and it poses the function, remembers the state, state continues from where it left off. So this is how a generator is work. So if I have to, you can say, explain visually, a normal function, you can say, returns the end function. After putting the end in the function, it basically, our function is basically completed. But while in the generator, if we use yield keyword, it basically poses the, you can say, execution of the function and saves the, you can say, list, or you can say save anything else. Now for the thing, you need to think of, you can say, we have two examples here, ready example. So it, these are two examples of, you can say, generating. First is the list of numbers from, you can say, 0 to, you can say, the large number that we have written here, and the number represent basically a million. Yeah, so a million number is going to return us, but every number is going to be squared off. So this is a list, but when we put a, you can say, parenthesis here, that same list comprehension becomes a generator, because at this time, because this list is basically stores everything. This list is going to store everything into memory, and that becomes heavy for our use case. While when we are using generator, it basically generates a location of the memory, and it basically produces on demand and is lightweight. This nums is a generator which produces the result on demand that makes it light. Now, how to basically use this generator expression? Of course, we can use the list comprehension as it is, but when you are talking about this, you can say generator. How we can use it? We can simply say for I in nums and sorry, and we can just simply do nothing, or maybe let's put a test here. Importing the time library will help us. So if I say import time, I will tell you about this time library later. But for now, just learning purposes, let's write a for loop for I in nums. Rather than that, we can just say time dot start dot what should we do? Time dot time, and then what we say we can just put a pass statement rather than that, and we can just stop the time a, and rather than that start, and here we can say end, and we can say time dot time, and at last we say print start minus, or rather than end minus start. This will give us the seconds of execution, and this, let's do the same for the generator and see what is the you can say effect of time that is present. Now when I try to run this program, as you can see, the difference of the time is quite different for us, or maybe we should try different time. So our first list actually return us something like 0 point some time for execute, but rather the other thing is taking some more. Okay, we have imported time, then we are generating a list. Okay, maybe we are doing something wrong here, and let us try to execute it again. So here, what we can see is the generator is taking less time than the numbers. But I believe there is an issue with my interpreter. Why is it showing the opposite result? I don't quite get it. Let me ask it for some kind of, let's say, okay, let's change the number to simply x, and maybe the computation is what making this thing little, you can say, complex, and making us think like, okay, the generator is taking time. So the generator basically starts, you can say, shines when we are doing some kind of complex calculation. Like let's say we are raising x to the power of 10. So in this situation, still then basically, oh, so at the back end, what is happening is the generator is basically generating the, you can say, output. And oh, we forgot to actually raise the power here. So what is happening here? Let me just break it down. So the generator is taking more time, maybe due to the pre-computation that is happening here in the list comprehension. But that should not be the case actually. So why is it? Computation pre- okay. I'm confusing some things here. So basically, generators are efficient in the time actually. Sorry, generators are efficient for the memory, but not for the time. Uh, Let me just mention that. Left wait for memory. So I was basically mixing two concepts. So yeah. So of course the list is taking less time because it is pre-computing this x raised to power 10 and then storing it to the list, and that is fast because we are talking about the computation time. But when we are talking about the memory for the generator is actually, you can say, more efficient and managed, and that is why the operator is working just fine. So, and also there is one more thing to keep in mind when we are talking about the generators, and that is the common mistakes that everyone does is that sometime we create an infinite generator which basically runs for n time. So this kind of thing is something that you must ignore. And the if you forget to, you can say, put yield here, so that is not a generator, and that is just a function that is going to throw an error. And also you can't expect a generator to restart automatically, so that is something that you must keep in mind. So with this note, we have actually completed the iterators and generators. So next video, we are basically going to implement these concepts in our project and see how we can basically make our project more efficient and more, you can say, readable and more understandable. That's all for now. Thank you for watching this video. Let's meet in the next video.